And we'll talk about matter. Today we're going to kind of start the transition between matter and measurement is what we kind of will be doing today with that. So please be mindful that we're in that transition between matter and measurement. One of the things that we had not done yet is define what a chemical change is, and that is involving the formation of another substance. That is the trick. It's the formation of another substance, and that is a tricky thing. Okay. I don't know if it's like Run DMC, it's trick to rock around, but it is a tricky thing to identify. Because a permanent color change, the first indicator, you can take a sheet of paper, and you can take that sheet of paper and you can put a permanent marker on it. And when you do that, you're like, hey, look, it's a permanent color change. Is that the same thing? No, it's not. It's still paper. You just changed the color, but it's still paper. Okay? Using a Sharpie, a highlighter, or something like that does not actually change what it is. Burning something is a permanent color change. Some of the chemical reactions that we do or will do in class is a permanent color change. An odor or bubbles from a gas being formed. So boiling water is not a chemical change. You're changing the state in which it's found. So we have to be careful about what's being done. Right? When you did your mineral identification and you did a droplet of a couple drops of diluted acid onto the carbonate, it bubbled and fizzed. You mix baking soda and vinegar, it bubbles and fizzes. You put Mentos and Coke, very large bubbling and fizzing. Those are chemical changes. Something new is being formed. Heat or light is being released. Now, turning on a light can be, but doesn't always guarantee that it is. Believe it or not, lighting a match, it is a chemical reaction. It's a chemical reaction that just requires a certain amount of friction to get it going. And once it hits that amount of friction, we're good. And because a heat or light is being given off with it. Now, the most difficult one to identify is the formation of a precipitate, because you have to kind of know what's going on. You need to have two solutions making a solid. And that solid doesn't look like it normally should. Because that solid just looks like snow globe stuff sometimes. So it doesn't look like, whoa, that's really awesome. It's kind of the more boring of them in some cases, but it's still necessary. How we identify these, and we will use these 4 ways to identify chemical reactions in the future, not just this unit. Separation of mixtures, how do we actually separate them? Depends on the kind. The type of mixture we have. If it's a heterogeneous mixture, separation of mixtures can be done using filtration. Now, there's more than one type of filtration. The filtration that we have here is depicted with what's called a gravitation filtration, meaning we're using gravity, which should make sense. These types of filtration are usually ones where you want a little bit of the filtrate, the liquid in the test tube. Okay, you want the filtrate, the liquid in the test tube, but you also want the residue. Okay, you want a little bit of both. Now, normally this funnel here wouldn't be just sitting there in thin air and just kind of being held there or held there. A lot of times gravity filtrations take a long time, so you set up a little system for it to work in that manner. We will use what is called Buechner funnels. Buechner funnels use a system, Bernoulli's principle actually, to filter things out. In Buechner funnels, we do a filtration where we're not worried about the filtrate, the liquid. We are only worried about the filtration or the residue at the end. That's all we worry about. If you can't see that there's a difference, that is where distillation comes into play. Those of you that go on to bigger and better things and take organic chemistry will find yourselves doing distillations. You're separating things based on some physical properties. You can't separate them based on the fact that their densities are there, like oil and water don't mix. You can separate them based on their physical separation because they're a heterogeneous mixture. If you had vinegar and water, you can't separate that out as easy. That way, you would need distillation. Acetic acid boils at a different temperature than water. If you had ethanol and water mixed, the only way to separate those, well, freezing I think could, but distillation would be your best bet. One of the big labs that I did in a class was having us do a lot of this filtration and distillation. And so it's all based on what do I have and how much do I need to get rid of. Another way of separating things is called chromatography. It separates substances based on different solubilities of a solvent. I'm not a big fan of doing this in the classroom because it can take a long time. But it is a method that is used sometimes. So that is why we still introduce it, still talk about it. Now we get to switch into, from matter, now we switch into more of the measurement part. This is the part I like, where we have this separation here. Now you have two different things, qualitative and quantitative. Okay? Pay very close attention to some of the lookings. So L is for looking. Qual. Quant. N is for numbers. Tells us how much is present. Qualitative just tells us what is present. Can we see it? And that's not always looking, but there's no numbers really involved with it. Okay? It's either yay, it's there, or no, it's not. And even if it's not, that doesn't mean that it's not there. It's just not there to the degree that we can detect at that level. And so we're going to use the metric system. I like quantitative numbers because based on my training. So quantitative tells us not just what's present, but how much. We are going to use the metric system. The metric system is an SI system. There's something base for each one, the base units. These are on the back of your periodic table. So it's not necessary to frantically write down every single one of these base units. So the periodic table for this class is there. And a lot of teachers will give you these things. Sometimes they match them up. I don't like doing those types of tests. Now, when it comes to prefixes, that's a big one. Not all of these are ones that we even worry about as well. There's some that we worry about more than others. Now, mastering chemistry might have you look at more of them. I believe it is table 5 in your book. And remember, you do have a book that is digital. So writing down table 5, very important. Ones that we use in the classroom very frequently. Are those 4? The kilo. The only larger prefix that is lowercase. That's because a capital K is for Kelvin. Centi, milli, and micro. The micro looks like a U with an M. But it's a U with a tail in front. Okay? It's a U with a tail in front. But if you look at it, it can also look very much like a sloppy written M, doesn't it? Yeah. It can. So that's where that also can come into play. But it can go as small as zepto and as big as peta, and it can even go bigger on either end of that. Okay? But these are just some of the common ones. The ones that I highlighted, kilo, centi, milli, and micro, those are the ones that we really do the most in here. Most of those you already have memorized.